A box starts at 6 p.m., but its children stay inactive for 4 hours. The culprit: a child job with its own start times overriding the box's schedule. Let's break down box jobs and nested boxes in AutoSys, how it works, and the exact mistake behind that failure. In this lesson, we'll demystify AutoSys box jobs and nested boxes. You'll learn how boxes control child job timing, why a running box doesn't mean children are running, and how to debug the most common production issues. A box job in AutoSys is like a project folder. It doesn't execute code, it manages the start conditions of its child jobs. Children can only start when the box is in running state. The box succeeds only when all inner jobs succeed. You can nest boxes inside boxes. The parent box must be running before the child box can start. The parent succeeds only when all child boxes and their contents succeed. The topmost box is called the super box. The core mechanic: a parent box's date conditions override the timing of all child boxes and their jobs. If the parent has date conditions equals Y, the entire subtree waits for the parent's start time. Setting date conditions equals N on a child does not bypass the parent's timing. Here's a typical setup. The box out box starts at 10 p.m. Job A runs immediately. Job B waits for Job A to succeed. But remember, children still need their own conditions met, like machine availability or not being on hold. This is the JIL definition. Notice the box has date conditions and start times. Job A and Job B have box name pointing to out box. Job B has a condition on Job A, the box controls the overall schedule. Here's a nested setup. The parent box master out box contains 2 child boxes, edl box and reporting box. Reporting box waits for edl box to succeed. Inside edl box, there's a job edl extract. Notice how child boxes reference the parent via box name. The condition on reporting box ensures it waits for edl box. This creates a clear dependency chain. Use autorep j box name d grep I term to see the current box termination setting. If it shows default, child jobs will keep running after the box fails, a common production trap. To see every job inside nested boxes, use autorep j box name %s, which lists all children recursively with their status. This helps find the root cause of a failure deep in the hierarchy. The box termination attribute and box success syntax are available in AutoSys R11.3+ and CA Workload Automation I11.3+. In older versions, box termination may not exist and box does not support status filters. Verify your version with autorep v. When a box is running but children are inactive, the problem is never the box. Check the child's own conditions: start times, condition dependencies, on hold status, and machine availability. Use autorep to inspect. These commands are your first line of defense. Autorep jjob d shows full attributes including date conditions and start times. Auto status checks hold I status. Autorep m checks machine availability. This is the most common mistake. A child job with its own start times will wait for that specific time, even if the box started hours earlier. The box shows running, but the child stays inactive until the clock hits 22:00. A box job status is a facade. A box with 0 jobs inside exits 0. A box with 50 failed jobs that all have ignore exit code still exits 0. Never trust the box status for upstream dependencies. Always query the box's children directly. The autorep w option shows the box's running children. In this example, the box shows success, but the real pipeline health is in the children's statuses. A condition like S, box A waits for the box to start, not complete. If you need to wait for a box to finish, use box name success. Otherwise, you'll trigger downstream jobs prematurely. Here are 3 approaches. The first is wrong, it triggers on box start. The second conditions on a specific child job. The third uses to wait for the box to end with success status. This is the same issue we highlighted at the start. Here's exactly why that happened. The box started at 18:00, but the child job had date conditions, 1 and start times, 22:00. The child was waiting for its own start time, not just the box's running status. The operator never checked the child's JIL definition. A child job had date conditions, 1 and start times, 22:00, so it waited until 10 p.m. even though the box started at 6 p.m. The fix removed date conditions from child jobs, letting the box control overall timing. The fix was simple: remove date conditions, 1 and start times from all child jobs inside the box. The box's schedule controls timing. They also added a pre-flight script to flag child jobs with their own schedules and a monitoring alert if a box runs too long without children starting. This is the exact mistake from the incident. The child job had its own start times, causing it to wait until 22:00 even though the box started at 18:00. The operator spent 2 hours troubleshooting before discovering the child's attribute. When debugging box issues, always start with the children. Use autorep jchild d to see date conditions and start times. Check auto status for hold ice. Verify machine status with autorep m. Let's run through some common interview questions. What is a box job? Container for grouping jobs, no command execution. When is a box in success? Only when all immediate children succeed. Box running but children not starting? Check children's conditions, start times, and hold machine. And a few frequently asked questions. What is a box job? A container for other jobs, no command execution. When does a box succeed? When all inner jobs succeed. Why are children not starting? Check start times, conditions, and hold machine. To recap, box jobs are containers that control child job timing. Parent date conditions override all children. Children inside a box should generally not have their own start times. And a running box does not mean children are running. Always check children's conditions. Ready to go deeper? Up next, file watcher jobs in AutoSys, then JIL one-time job overrides, then AutoSys job scheduling and time conditions. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.